Today we're going over Newton's second law and how to solve basic Newton's second law problems. Most people in physics tend to memorize formulas and not understand how to apply them, but today I'll show you step by step how to approach any problem using what we've already learned. In the last video, I showed you how to make free body diagrams, and today I'll show you how to use that to solve these types of problems. So first things first, what is Newton's second law? Newton's second law is the sum of forces, or net force, is equal to mass times acceleration. And you can put these kind of vectors over F and A to demonstrate that force and acceleration both have direction and magnitude. So let's break apart each term. The sum of forces just means net force acting on a block, so net forces. Net is just the summation of all the forces, so if you have more than one, you would add them appropriately. Make sure your sign is correct. And then we have, this is your mass of the object that is in moving or having force applied to it. And this is your acceleration. So Newton's second law, so this relates forces to motion, right? How can, if I push on something with an X amount of force, that object moves, and Newton's second law relates them together. So let's go through some general steps on how to solve Newton's second law problems. Steps. So first things first is you want to identify your system and forces. So identify system and all forces. Step 2 is draw your free body diagram. If you don't remember how to do a free body diagram, check out my previous video. But in a free body diagram, you put all forces that are touching or acting on an object. Step 3 is write your net force equation, or F equals ma. And then step 4 is solve. So these are kind of the steps to approach any type of problem. So let's start with an easy example. We have a 5 kilogram box is pushed with a force of 20 newtons on a frictionless surface. What is the box acceleration? So first things first, we want to identify the system and all forces on that system. So our system in this case is a 5 kilogram box. So I'm gonna draw a little box here. I'm gonna say this is 5 kilograms, right? M is 5 kilograms. And the box is pushed with a force of 20 newtons. So I'm going to say the box is pushed this way with 20 newtons on a frictionless surface. So frictionless surface means there's no friction. So we have a box on the ground, there's no friction, it just slides perfectly in the direction of the force. What is the box's acceleration? So next step is draw our free body diagram. So I'm going to draw it here in red. So our free body diagram, we have the box. We have the box's weight pointing down, right? Weight, and that is just mg. M in this case is 5 kilograms. G is 9.8 meters per second squared. We have our normal force. We have the ground pushing up onto the box. And then we have the 20 newtons of force, right? And notice how we don't have anything to the left. So clearly from this free body diagram, we can see the box will be moving towards the right. But now the next question is, how fast is it, or how much is it accelerating? So now that we have our free body diagram, let's put it into our formula. And our formula again is F is equal to ma. F again is the sum of all forces. And notice how we have forces in three different directions on the box. However, the box is only accelerating to the right, right? It is not accelerating upwards. The ground is not pushing and flinging the box in the air. The box is not accelerating into the ground. It is only accelerating to the right. So I'm going to draw a little coordinate system that this is my x direction, this is my y direction. We have no movement in the y direction, only in the x. So I'm going to say, I'm going to look at only forces and acceleration in my x direction because that is my critical direction. So let's plug everything in. So for forces, all we have is 20 newtons in the x direction. We have mass, which is 5 kilograms, times acceleration in the x direction. And then now let's solve for acceleration. So we move the 5 over to one side. So we get acceleration in the x direction is equal to 4 Newton, or let me, 4 meters per second squared. And Newton over kilogram is equivalent to meters per second squared. And that is our final answer. All right, so let's try now your turn. We have a box accelerates on a rough surface at 5 meters per second squared due to a 10 Newton force. How much is the friction force that acts on the block? So go ahead and pause the video, try it on your own, and then I'll solve it in a few seconds. All right, hopefully you had enough time to try it out. Um, and here we go. Let's go ahead and solve it. So we have a box on a rough surface. So friction is present. And the box accelerates. I'm going to say it accelerates to the right at 5 meters per second squared due to a 10 Newton force. So there's a force on the block of 10 newtons to the right. How much is the friction force that acts on the block? Oh, and I forgot to mention the weight. So I guess if you tried it, you weren't able to solve it because you didn't have the mass. Let's say the mass of this object is 5 kilograms as well. All right, so if you want to pause it again, try it again. Sorry about that. Go ahead and try. All right, let's come back to it. Again, I apologize about that. We have mass of 5 kilograms. We have it accelerating at 5 meters per second squared due to a 10 Newton force. How much is the friction? So we have our system. Our next step is our free body diagram, where we have the box. We have our weight force, our normal force. We have 10 newtons to the right, and then we have our force due to friction, right? And that is everything we need on our free body diagram. Let's plug it into our formula. So the sum of forces is equal to mass times acceleration. Again, remember your coordinate system. You have your x and your y. We only accelerate in the x direction as we drew here. The 5 meters per second squared goes in the x. So I'm going to solve only in the x direction. So we don't need to worry about the normal force or the weight force for this problem. So let's write out what we know. So we have 10 newtons in the positive x direction minus the force of friction, and it's minus because it's pointing to the left. My coordinate system says that positive x is to the right, so anything to the left is a negative x. So we have the sum of forces in the x direction is equal to 10 newtons minus the friction force. And this is equal to 5 kilograms times 5 meters per second squared. So we get 10 newtons minus friction force is equal to 25. Now let's bring friction to the other side. We have 10 minus 25 is equal to the force of friction. And notice how in this case the force of friction is negative. So we get friction force is negative 15 newtons. That is our answer. So what does this actually mean? We have friction force is negative because we assume that friction is going in this direction. However, with the numbers that we came up with, the friction force shows that it's actually pushing in the other direction which we drew, so to the right, with 15 newtons of force. And that allows us to accelerate at 5 meters per second squared. And there you go. So those are some basic Newton's second law problems. In the next video, I will go over how to solve Newton's second law problems for inclined problems. So where we have angles, where we deal with angles and all of that. So if you need help with that, stay tuned for the next video. I'll see you next time.